بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله صلى الله عليه وسلم وبعد. Our lecture today is about the enamel. Upon completion of this presentation, students will be able to understand the physical and the chemical characters of enamel, recognize and distinguish between the microscopic and ultrastructure of enamel, discuss enamel surface structure, describe the age changes of enamel. The general characters of enamel. Enamel is the hardest mineralized tissue in the human body that covers the anatomical crown of teeth. It forms a protective covering of teeth to resist the stresses and forces of mastication, temperature changes, bacterial toxins, and acids. It is totally acellular, inert, non-vital, and insensitive. If we remove caries, it cannot replace or regenerate it, means it cannot renew itself. So enamel is dead tissue in biological term, but it is selectively permeable to ionic exchange. The enamel is ectodermal in origin, arising from the inner enamel epithelial cell layer, which is the most inner layer of the enamel organ, and the enamel organ arising from the dental lamina that arise from the oral ectoderm. So the enamel is ectodermal in origin. Enamel is formed by ameloblast cells, which undergo programmed cell death and are lost as the tooth erupts, and hence enamel cannot renew itself. The physical characters of enamel. Enamel color is translucent, varies from yellowish white to grayish white. Depends on the enamel thickness and the degree of translucency of enamel and degree of calcification and the homogeneity of enamel. At the incisal area may have a pleuroting, where the thin incisal edge consists only of a double layer of enamel without dentine in between. The thickness of enamel varies. Maximum thickness on the cusp tip and the incisal edge from 2 to 2.5 millimeter, and thinning down to a knife edge at the cervical margin in the permanent teeth and end abruptly in the deciduous teeth. The enamel is the hardest calcified tissue in the body due to the increased content of mineral salts and its crystalline arrangement. The hardness of a permanent teeth is more than the hardness of the deciduous teeth. The hardness at the surface is more than the hardness at the dentino-enamel junction. The hardness at the cusp tip and the incisal edge is more than the hardness at the cervical line. Brittleness. Enamel is brittle, especially when loses its elastic foundation of healthy dentin. The undermined enamel and the carious dentin makes the enamel more brittle. The permeability. Enamel can act as a semi-permeable membrane, permitting complete or partial slow passage of certain ions and dyes, mainly from the saliva or to the outer layer of enamel, but to a lesser degree from the pulp to the inner layer of enamel crossing the dentine. The chemical composition of enamel. By weight, enamel composed of 96% inorganic substance and 4% organic substance. The 96% inorganic substance is a form of hydroxyapatite crystals, which is hexagonal in shape, ranging from 0.05 to 1 micron in length, 300 angstrom thickness, 900 angstrom in width. Some molecules may replace the hydroxyl radical as fluoride, magnesium, strontium, carbonate, and sulfate. This is the basis for the national project of fluorination of drinking water, as fluoride has a strong bond with calcium, forming fluoroapatite crystals, as the fluoride ion replacing the hydroxyl group on the hydroxyapatite crystals, which is more resistant to the bacterial toxins. The crystals are arranged to form enamel rods or enamel prism. This is the enamel rod or the enamel prism. This is crystals, and this crystals are arranged by a specific way. We will explain it later. To form the enamel prism or the enamel rod, and in between this prism, the prism sheath and the interprismatic substance. So the crystals are arranged to form the enamel rods or the enamel prism. The 4% organic substance and water consists of 1 to 2% organic substance and 2 to 3% waters. The organic substance present between the crystals as a fine network or forming a cortex or envelope or a cover surrounding the crystals. The protein found in the enamel are of two main groups, the amelogenins and the non-amelogenins. The amelogenins are heterogeneous group of low molecular weight proteins, accounting for about 90% of the enamel proteins. They are hydrophobic and are rich in proline, histidine, glutamine, and leucine. Amelogenins have specific functions as in regulating the crystal graph and is suggested to have a functional role in maintaining spaces between the crystals. In the fully formed enamel, amelogenin remains in between the crystals and also surrounding them. Experimentally, absence of amelogenin resulted in the formation of hypoplastic teeth or enamel hypoplasia. The non-amelogenins constitute about 9% of enamel matrix protein. Enamelin, ameloplastin, and tuftelin are the important proteins of this group. Non-amelogenin are high molecular weight proteins and are rich in glycine, aspartic acid, and serine, and are reported to help in nucleation and growth of crystals. Tuftelin on the hands is localized to the dentino-enamel junction and is suggested to be involved in cell signaling. Experimentally, in the absence of ameloplastin, no structural layer of enamel formation is observed. Recently, amelotin, a new protein, was reported to be secreted by maturative ameloblasts. This protein is suggested to help in the enamel formation. By volume, the enamel consists of 50% inorganic substance and 50% organic substance by ratio 1 to 1. Histologically, or the histological structure of enamel is difficult to be studied in decalcified section due to its high crystalline nature. So it is studied by ground section. The crystals arranged by a specific way forming the enamel rod or the enamel prism. And if we do a decalcified section, the enamel is dissolved completely. So we will find the enamel space and no enamel in decalcified section. So if we want to study the enamel, we study it by ground section. The histological structure of enamel, we'll talk about the enamel rods, number, course, direction, diameter, length, the enamel rod by light microscope, transverse section and longitudinal section, the enamel rod sheath and interprismatic substance or interrod substance, and also by electron microscope we will talk about the enamel rod in transverse section and in longitudinal section. We'll talk about the Hunter-Schreger paint, incremental lines of enamel, cross-titration, brown stripe resius, neonatal line, the primary enamel cuticle, amelodentinal junction, hypocalcified area of enamel, which are the enamel lamellae type A, P, C, enamel lamellae type A, P, and C, the enamel tufts, and the enamel spindle. The enamel rod or the enamel prism. The enamel rod is the structural unit of enamel formed by the hydroxyapatite crystals, which are arranged by a specific way, as we said before. The enamel rod has numbers, diameter, length, course, The number of the enamel rod or the enamel prism ranging from 5 millions to 12 millions. 5 millions in the lower central incisors or the smallest tooth in the oral cavity. 12 millions in the upper molars or the largest tooth in the oral cavity. The diameter of the enamel prism or enamel rod, the diameter at the inner surface or the inner side of enamel at the dentino-enamel junction is small. The diameter is small at the inner side at the dentino-enamel junction and wide at the outer surface. The ratio between the diameter of the rod at the inner 3 to 4 microns and 6 to 8 microns on the outer surface is 1 to 2. This is due to the difference in the surface area between the outer surface and the inner surface of enamel. The course. Enamel rods are perpendicular to the amelodentinal junction. Enamel rods are perpendicular to the amelodentinal junction or the dentino-enamel junction, then run in a wavy course outward here. Just before the outer surface of enamel they become straight. A more spiral course or complicated course or twisted course or braided-like is noted at the cusp tip or the incisal area to give the maximum strength against the masticatory forces and is called gnarled enamel. Length. By this way, the enamel rod is longer than the enamel thickness due to its wavy course. The direction. The direction of the enamel rod perpendicular to the dentine surface. In primary teeth, the rods are horizontal at the cervical and central part of the crown, and then it changes gradually to become oblique in direction until they become vertical in the region of the incisal edge or the cusp tip. In permanent teeth, the direction of the enamel rod are similar to the primary teeth in the occlusal and the middle thirds of the crowns. But in the cervical region, the enamel rod deviate horizontally to apical direction. Deviate horizontally to apical direction. By the light microscope, transverse section, the enamel rod appear in cross section by light microscope as hexagonal, oval, round, or as a fish scales. Enamel rod don't have a regular geometry. By light microscope, the rod appear to be surrounded by rod sheath. Rods are separated from each other by interrod regions. Enamel rods have clear crystalline appearance permitting light to pass through them. The rod sheath and the interprismatic substance, or the prism sheath and the interprismatic substance. The prism sheath is the peripheral part of the enamel rod. The prism sheath here is the peripheral part of enamel rod that forms incomplete envelope around the prism, less calcified than the rod itself. The interprismatic substance separates the enamel rods from each other and highly calcified as enamel rod. It has different refractive index. The longitudinal section, the enamel prism appear as a parallel cylinders. The cylindrical prism appear to be divided horizontally into equal segments by less calcified dark lines, giving a striated appearance, which are called short increments or cross striation. With a longitudinal ground section of enamel, lines are right angle with the long axis of prism. This is called cross striation. By electron microscope will explain what we see in the light microscope. In the longitudinal section, the rod shape is somewhat like a cylinder and is made up of crystals. These crystals parallel to each other and parallel to the long axis of the innermost part of the prism and is called the prism core. The boundary between rods and interrod enamel, the crystals deviate, change their orientation 20 degrees. This region is delimited by a narrow space containing more organic materials. The difference in the angulation of the crystals will increase the spaces between the crystals, and so it will contain more organic material, and it's known as the rod sheath. The interrod regions around each rod, its crystal deviation are increased to reach about 60 degrees. Different angulation from those making up the rod. This difference in the crystal angulation results in difference in organic components and the refractive index of the prism and interprismatic substance is a function of Thomson process. So in longitudinal section, the rod shape is somewhat like a cylinder and is made up of crystals with long axes parallel to each other and parallel to the long axis of the prism. And this is called the prism core. The boundary between the rod and the interrod enamel, the crystals deviated, changing their orientation about 20 degrees. This region is delimited by a narrow space containing more organic materials as this rod sheath. The interrod region surrounding each rod is a crystal's deviation are increased to reach 60 degrees, different angulation from those making up the rod or the rod core or the prism core. This difference in the crystal angulation results in difference in organic components and the refractive index of the prism and interprismatic substance, and this is the function of Thomson process. In the enamel prism core, the crystals are so tightly packed here, and this is the prism core. So no or minute spaces were found between them for the organic material. So the organic material only forms an envelope around the crystals, while the abrupt changes in the crystal orientation in the rod sheath and the interprismatic region here leads to crystals not tightly packed, allowing more spaces between them for more organic material to be present. This accounts for the prism sheath to be visible in the light microscope as a dark band. The transverse section by electron microscope, the cross section appear as a keyhole in appearance. The head of the keyhole representing part of enamel rod with the apoptotic crystal parallel to the long axis of the rod and directed occlusally, and the tail of the rod represents the interprismatic region directed cervically, where the crystals fan out until become 60 degrees to the long axis. The transverse section of enamel prism revealed different patterns such as hexagonal, rounded, oval, or fish scale, and keyhole in appearance. The clinical comment on the enamel rods. Enamel rods interlock to prevent the fracture and splitting of the tooth. Enamel rod grooves also intertwine, thereby preventing separation. The rod direction in the crown is normally perpendicular to the incisal surface, which provide additional support in preventing the fracture of enamel. The rod that form enamel are woven during formation into mass that resist average masticatory impact of 20 to 30 pounds per tooth. Enamel is thin in the cervical area, where masticatory impact is the least, and thickest over the area of the crown cusp and the incisal edge where impact is greatest. Hunter-Schreger band. Hunter-Schreger band is an optical phenomenon, dark and light band, alternating dark and light bands, starting at the dentino-enamel junction and in shortly before the outer surface of enamel. They present at the middle and cervical third of the crown and absent in the region of gnarled enamel. This optical phenomenon is seen when examining the longitudinal ground section of enamel under oblique reflected light, and this is due to the wavy course of the enamel prism, as the light will fall on this part of the enamel prism and reflected and fall or run parallel to another piece of the enamel prism and transmit the enamel prism itself. So light will reflect it, and here the light will pass through the enamel prism. so it appears as alternating dark and light band, and this is called diazone and parazone. The dark band diazone and the light band called parazone. The incremental lines of enamel: cross striation, brown stria of rhizis or incremental line of rhizis, neonatal line. The cross striation, or the short increment. The enamel rod is built up of equal segments separated by dark lines that give it striated appearance. This can be seen by partial decalcification or etching of enamel using mild acids. This is due to the rhythmic apposition of enamel matrix by ameloblast during amelogenesis and represents the daily rate of secretory activity of the ameloblast, or the daily formed enamel. By scanning electron microscope, the segments are of uniform size. The brown stria of rhizis, or the incremental line of rhizis, and they are incremental lines indicating the successive or the rhythmic deposition of enamel layers during the formation. It's not stained but appear brown due to the difference in the refractive index due to the difference in the organic component of enamel. In the longitudinal ground section of enamel, the brown stria of rhizis arise from the amelodentinal junction upward, outward, around the cusp tip and the incisal edge to the dentino-enamel junction again. It does not reach the outer surface of enamel at the cusp tip or the incisal edge, but reach the outer surface at the cervical area, forming the what's called the pericymeta. So at the incisal ridge and the cusp tip, they appear as a brown band form a circles. Don't reach the surface. They arise from the dentino-enamel junction upward and outward, surrounding the tip of the dentin. At the middle and cervical third, they reach the outer surface of enamel and become represented as series of transverse depression called pericymeta. Brown stria of rhizis in transverse ground section of enamel. The incremental line of rhizis appear as a brownish concentric ring similar to the growth rings in concentric cross section of tree. The cause may be due to the rhythmic formation of enamel, where period of activity of ameloblast alternate with period of rest. When the incremental line are broad, it means that the rest period of ameloblast is prolonged. When the incremental line are close to each other, it means that there is a metabolic upset. The neonatal line. Neonatal line is an accentuated incremental line, one of the incremental line, but it appears as accentuated line that apparently reflect the great physiological changes occurring at birth in enamel. It separates the prenatal formed enamel from the postnatal one, before and after birth. So this is the prenatal, or the enamel formed before birth, and this is the enamel formed after birth, or the postnatal enamel, and this is the neonatal line. It is therefore present only in the deciduous teeth as well as the first permanent molars. This is the teeth partly formed before birth and partly after birth. It is due to the abrupt changes in nutrition and environmental conditions that occur at birth. The prenatal enamel is thought to be more homogeneous than the postnatal enamel due to the more protected condition and the constant nutrition of the fetus. The primary enamel cuticle or Nismus membrane. Primary enamel cuticle or Nismus membrane, delicate organic membrane that covers the crown surface of newly erupted teeth. It is the last secretory product of the enamel of the ameloblast. Its thickness 0.2 micron. It has a structure similar to the basal lamina of the epithelium. It is organic material worn off gradually from the surface exposed to mastication or toothbrushing, but may remain for life in sheltered area as the gingival sulcus and the depth of pits or fissures on the occlusal surface. The amelodentinal junction. Amelodentinal junction appear as a scalloped line with the convexities toward dentin. It is thought that this scalloped line or these scallops provide undercuts which cause firm attachment between enamel and dentin. But it is found that firm attachment is still present even in a smooth dentino-enamel junction. The cause of firm attachment between enamel and dentin appear to be due to the interdigitation at the dentino-enamel junction between the fibers of the first formed layer of dentin, which is called mantle dentin, and the fibers of the organic matrix of the first formed layer of enamel, and consequently the interdigitation between the hydroxyapatite crystals that are deposited during the mineralization of both structures of enamel and dentin. The hypocalcified area of enamel. Enamel lamellae. Enamel lamellae is a thin leaf-like structure. Thin leaf-like structure extended from the enamel surface to a considerable distance in the enamel till the dentino-enamel junction. Sometimes it may be extended to the dentin. There are three types of enamel lamellae. Enamel lamellae type 1 and called true enamel lamellae, and it is limited to the enamel only. It's formed of organic substance with a slight calcification. It means that it's hypocalcified enamel segment caused by mild stimulus as abnormal tension, leading to some disturbance in enamel calcification. The clinical consideration of the enamel lamellae, it acts as means of spread of dental caries. The enamel lamellae type P, if more severe stimulus occur, a crack may be formed and may be reached to the amelodentinal junction. Here. The crack occurs before eruption of teeth, may be filled with cells, epithelial cells of enamel organ. So the cells in the depth of the crack will degenerate, while those on the surface remain vital and produce a hornified cuticle or filled with cells of the adjacent connective tissue that differentiate into cementoplast and may lead down cementum. Enamel type C, this is occurred due to severe stimulus. The crack occur after eruption of teeth, so will be filled with organic material from the saliva and may extend it to the dentin. The enamel tufts. Enamel tufts is a rapon-like structure, or like tufts of grass. Start from the amelodentinal junction to about 1/5 to 1/3 of the thickness of enamel. It's hypocalcified enamel rod and interrod substance. They resemble tufts of grass when examined in ground thick section with low magnification, best examined in transverse section. Enamel tufts are more numerous than enamel lamellae. Tufts contain greater concentration of enamel protein than the rest of enamel. The clinical comments here: when caries has spread from the tooth surface to near the dentino-enamel junction, the hypocalcified tufts allow a lateral spread along this junction. Other hypocalcified structure in enamel, such as lamellae and incremental lines, can also modify the spread of caries. Enamel spindle. Enamel spindle are odontoplastic process. That pass across the dentino-enamel junction into the enamel. They are thickened at their end like the drumstick, or it is drumstick-like, so it's termed enamel spindle. The odontoblastic process extends between the inner enamel epithelium before the hard substance are formed, as the dentin is formed first. They are best demonstrated in longitudinal section, where the organic content of the spindle disintegrates and replaced by air. So the spaces appear dark in transmitted light microscope. Here, this is the odontoblastic process, and this is the extension into the enamel. And here we must note that the odontoblast and its process are mesodermal in origin, while enamel is ectodermal in origin. So the enamel spindle is a mesodermal structure present inside ectodermal structure, or the enamel spindle is the only mesenchymal tissue inside the enamel. The surface structure of enamel: structureless enamel, pericymata, rod end, cracks, and epiprellar cementum. The outer structureless enamel. The outer structureless enamel is a prismless enamel, occurs in the outermost 30 microns of enamel. In all deciduous teeth and 70% of permanent teeth, most common toward the cervical enamel, is common on the cusp tip and incisal edge. No prism outline, and the hydroxyapatite crystals are unparalleled to each other and perpendicular to the outer surface of enamel. Tomes of process are absent, so it is called a prismatic or structureless enamel. It is hypercalcified than the bulk of enamel. The inner structureless enamel layer is first formed layer of enamel against the dentin surface. It's formed before the ameloplasts develop their tomes of process, therefore lacks prismatic structure, and the hydroxyapatite crystals are also run parallel to each other and perpendicular to the amelodentinal junction. Pericymata or imbrication lines. The pericymata is a transverse wave-like grooves cleaved to P, an external manifestation of the brown striae of rhesus or the incremental line of rhesus. They are continuous around the tooth and are parallel to each other and to the cemento-enamel junction. 30 pericymata per millimeter in the region of the cemento-enamel junction, and 10 pericymata per millimeter near the occlusal surface or the incisal edge. So it decreased toward the incisal edge and the cusp tip. So it appears here, this is the pericymata, or the grooves, and this is the brown striae of rhesus. The brown striae of rhesus will reach the outer surface of enamel. It appears as transverse grooves, and this transverse grooves is more in the cervical area than on the occlusal or at the cusp tip area. Enamel rod end. The enamel rod ends are concave, multiple concavities, varies in depth and shape, shallow cervically and deep occlusally and incisally. Cracks extend for a varying distance along the surface and appear as jagged lines in various regions of the tooth surface. Epiprellar cementum. In 60% of cases, the cervical area of enamel is covered by cementum. It's called epiprellar cementum. The cause: when the reduced enamel epithelium retracts or tear off from the cervical region during the tooth development, the connective tissue cells come in contact with the enamel surface and differentiate into cementoplast, depositing cementum on the enamel surface. The age changes of enamel: attrition, decreased permeability, increased hardness, and color changes. Attrition. Attrition is a physiological mechanical wear of tooth hard structure in occlusal or incisal surface as a result of tooth-to-tooth contact, or wear of proximal surface of tooth due to slight mobility of teeth in their sockets. Attrition occurs in permanent teeth and deciduous teeth. Attrition in permanent teeth is more severe and may reach to the dentine surface because permanent teeth has longer lifespan than the deciduous teeth. Attrition in deciduous teeth may be severe because they are less hard. Attrition appears as a small, polished, shiny area on the cusp tip or incisor ridge, followed by gradual reduction in the height of cusp and flattening of the occlusal surface, resulting in decrease in the vertical height. The permeability with age decreased, or the permeability decreases by time, especially from the outer surface of enamel, while it remains from the dentine surface constant. Alteration in the chemical composition of enamel. The ionic exchange between enamel and saliva lasts through life, so the enamel becomes more mature. Its inorganic content increases up to 98%, and this is a secondary maturation. Localized increase in fluoride and nitrogen make enamel more resistant to decay. Discoloration. Teeth darken with age, although it could be due to the addition of organic material to enamel from the environment. It also may be due to deepening of dentine color seen through the progressively thinning layer of translucent enamel. Etching. Etching with diluted acids such as citric acid may alter the surface of enamel. These dilute acids selectively etch the end of enamel rods and provides adherence of a plastic sealant to the surface of the enamel rods. The rod sheaths resist the demineralization to a greater extent than the rod core. The core of the crystal is rich in coronated apatite and is more sensitive to decalcification or demineralization than the periphery or the peripheral part of the hydroxyapatite crystals. The purpose of this procedure is to produce an intact surface and thus preventing the caries. Thank you.